everyone, welcome back to my channel Ace2Excel. In today's video, we'll talk about registers. Registers are basically a application of flip-flops. We have talked about flip-flops. So when I say flip-flop, flip-flop needs to be applied somewhere. So one application of flip-flop is register. Flip-flop circuit can save 1-bit data. So if we want to save multiple bits, say you want to save n-bit data, we need n flip-flops for the same. So registers can also be defined as group of flip-flops combined or cascaded to store n bits. Now, when we say flip-flop, type of flip-flop which we use in register is D. D flip-flop, known as data flip-flop, has other name as transparent flip-flop. It shows that value at output what is available at input. Now, storage of data can be done in multiple ways. Like in the way input and output is done, or depending upon its application. So if we say input and output, on the basis of this, there are 4 types of registers. First one, SISO, serial in, serial out. Second, SIPO, serial in, parallel out. Then is PIPO, parallel in, parallel out. And last is PISO, parallel in, serial out. These 4 types are totally dependent upon that how data enters. If data enters serially, it is serial in. If data comes out serially, it is serial out. Similarly, if data comes serially inside and is taken out parallel manner, it is known as serial in, parallel out. If data enters in the circuit in a parallel fashion and comes out in the out of the circuit in a parallel manner, it is PIPO. Else, the last one is parallel in, serial out. Now one by one we'll take up all these types. Now the point which one should keep in mind here is that if n bit data is there, n clock pulses are needed to bring the data completely inside. n bits के data को completely inside the circuit लाने के लिए we always need n clock pulses. We used 4-bit data, and at 4th clock pulse the complete data was in. Now this is my first bit which has come out. Next is at 5th clock pulse. Now after the data complete MSB is inside, has entered, next value is 0. So now this one shifts here, this 0 shifts here, and this one is now again out. At 6th clock pulse, another 0 enters, this 0 shifts here, next one shifts here, and this 0 data is again out. At 7th clock pulse, the complete data is out. So if we go by means that if I have n bit data, it requires n clock pulses to completely load inside, and further it requires n minus 1 clock pulses to come out. I'll try to explain you the things which we are technically talking about. We had 4 bits data. For completely loading, 4 clock pulses were needed. So to completely load, I required 4 clock pulses. Further, to bring it serially out, n minus 1, that is 4 minus 1, that is 3. Further 3 was required, and total clock pulses further 3, and total clock pulses which were needed are 2n minus 1, or it is equal to 7. That is known as serial in, serial out. Data will come inside, data अंदर आएगा serial manner में, and data bit by bit from one flip flop it shifts to another, and then to another, and then to another after every consecutive pulse, and that is serial in, serial out register. The total number of clock pulses required in this case to completely load and then bring out the data is always equal to 2n minus 1. Next we will talk about SIP. Next we are going to talk about SIPO. Data will come inside in a serial manner, and data will come out in parallel manner. Now again we'll consider it for 4 bits. 4 bits means 4 flip-flops. 1, 2, 3, 4. Type of flip-flop again D. So we'll quickly label it. Now data comes serially in, that means serial connection needs to be done, and data comes parallelly out, that means tapping out of output should take place. Now let us say at initial point that is initially, before any data comes, all flip-flops are in clear position, that is every value is 0. And let us for example take the data as 1111. This is LSB and MSB. Now at first clock pulse, LSB enters in DA and QA becomes 1, rest all are zeros. At second clock pulse, second one enters and the first one becomes input to the second flip-flop, and hence QB's output becomes high and rest all are 0. At third clock pulse, third bit enters and now the 1 shifts to third place and output will be available at simultaneous values. Now at fourth clock pulse, last one enters and somewhere complete data is inside. So for loading the data, as I told you previously, for n bits you require n clock pulses, and in case of SIPO, at 4th clock pulse, what is the value of QA? QA is 1, QB is 1, QC is 1, QD is 1. Somewhere the data is serially out at the 4th clock pulse. So we do not need a single more clock pulse after this. So once you load the data, which always require n clock pulses, your data will be out. This is known as serial in, parallel out. Now we'll talk about parallel in, parallel out. Data comes inside in parallel manner, data goes out in parallel manner. For this I'll be considering 3-bit videos, so 3-bit word to be entered. So I'll be having 3 flip-flops, DA, DB, DC, and the data will be entering independently and output will also be coming independently. The only thing is clock is same. Let us say the data is 1, 0, 1. Initially, let us say the scenario is initially all are zeros. At first clock pulse, QA will have 1, QB will have 0, QC will have 1. That is, in total 1 clock pulse, complete data is in as well as out. This is parallel in, parallel out, the easiest of all the type of registers we have done till now. One which is left behind is PISO. I'll be soon coming up with that video because it is an exclusive video. Thank you.